Okay, welcome to the second lesson of Math 1 Logic. In this lesson we're going to look at the laws of the algebra, and in fact if you've already done the set theory part, then these are identical. And so the laws in set theory and the laws of the algebra are really able to be translated one to one, no problem. So let's have a look at them. If we look at the first simple laws, and then we look at P or P, and of course that's equivalent with P. P and P is also equivalent with P, and then because we have a math class, we give it a nice expensive law, idempotent law. And if you compare it with the set theory, this would mean set A united with set A, and of course that is identical with A. And so this or in logic you can translate with the union in set, and then the law is exactly the same. Same applies for the identity law. So if I have P or false, then it's the same with as P. And if we compare it, this one with the set theory, so the set A or and then united with false would mean the empty set. Okay, if we unite A with nothing, then it's still the same set A. So in this way you can compare all of these laws with set theory. If we look at the next one, complement law, so P or not P, so I'm saying something like it's raining or it's not raining. Yeah, of course, that's always true. So P or not P is always true, equivalent with true. P and not P, so it's raining and it's not raining. Yes, then I'm really talking gibberish, so that's equivalent with false. And then the simplest one, it is not, it's of course again equivalent with P itself. Involution law in a more expensive word. Then we also have our commutative, associative and distributive laws, which are exactly the same as in set theory, or if you want to compare it with your high school calculations, if we look at 2 plus 4, that is of course exactly the same as 4 plus 2. Commutative law. And this also applies for the or and the and. Commutative. Associative means that we can put the brackets anywhere we like. So if I would say 2 plus 4 plus 3, that would be the same as 2 plus 4 brackets plus 3. Okay, associative law. And again, that one also applies for the or as well as the and. The only difficult one is the distribution law. Let me make some space. So distribution law you can compare with your math high school, like 4 times 3 plus 2. And so the difference between the associative law is that we now have two different symbols. So we have an or and an and, or an and an or. So if we first look at this one in high school, then we all know that this is the same thing as 4 times 3 plus 4 times 2. So 4 times 3 plus 2, that would give us 4 times 5 would be 20, and that is exactly the same as 12 plus 8, which is 20. Distribution law. And the same distribution law is applicable in logic. And then it doesn't matter whether we start with an or and then have between brackets the and, or the other way around. So start with an and then have between the brackets the or. So distribution law is the same as what we've known from multiplication and adding. So if you remember that, then on the exam won't give you any problems. There's also a nice law which we saw in set theory, which is called De Morgan's law. And in the last lesson 1, we already have got an example of this law with John speaking French and Sean speaking English thing. If we look at this law, De Morgan's law, that's one we really will use quite a lot. And then the best thing to check whether this is really true is to make a truth table. So if we make a truth table, let's do the first one, this one. So not P or Q. Then we have two propositions named P, Q, and there can be 4 possible combinations of values. So with 2 propositions, I always have to investigate 4 options. Okay, if I start with the left part and we say P or Q, that would give us 1, 1, 1, 0. And then we'll put a not in front of it, not P or Q, which will give us 0, 0, 0, 1. Okay, then on the other part, we have not P. Okay, so that would be 0, 0, 1, 1. And we have not Q, which would be 0, 1, 0, 1. And then the final one would be not P and not Q. So that would give us 0, 0, 0, 1. And then what we need to establish is if this column is identical to that one. And indeed, these are identical, and that's the definition for equivalent. So not P or Q is equivalent with not P and not Q. De Morgan's law. And please, as a practice, as an exercise, do the second one yourself with making a truth table. So if we look at all the laws in one overview, it's this one, and you can also find it in the book, but unfortunately in the book they made a small mistake. So with 8b they put a true in there, and that should be a false. So even in mathematics books sometimes errors occur. Then the last law I'd like to discuss with you is the absorption law. And the absorption law you can remember best if we look at set theory. And so again we can translate, let's do the first one, with a set visualization. So for instance P, we make it set A, the OR changes into a union, and then we have between bracketed set, same set A again, with an intersection, the AND we change into an intersection, and another set. Okay, and apparently this one is equivalent with A. Well, if we look at sets, let's draw a set A. Okay, let's make a set B with a different color, B. Then the union of A with A through B, then let's first make A through B. That's this one here. And then if we unite it again with A, okay, let's take a different color. If we unite it again with A, then that's this complete part again. So if you make a small drawing, then the absorption law immediately stands out to you, and you will understand that this is the situation. If we ask you on the exam to prove the absorption law, then you have to make a truth table again, just like we did with De Morgan's law. Okay, let's look at a simple exercise. The question is simplify by using the laws. And what we'd like you to do is every time you make a step, tell us what law you're using, and then the most simple ones you can omit. But let's start with this one. So not P or Q or P. Well, what's the first law you're going to do? And then you put it between brackets, and then hopefully you see that you're going to use De Morgan's law. So this is the law you're going to do, and then this will be equivalent with, Okay, apply the Morgan. So that would be not P. The or changes into an and, not Q. And then don't forget to keep the last part. And so with applying the Morgan, we have this change. We have this equivalent relation. Okay, and now we have not P and not Q, or P. Okay, what law will we use now? And then maybe distribution law comes to mind, because I have an or and we have an and between brackets. So distribution law. So this will be equivalent with, okay, not P or P. So we have this or into the brackets. Then we leave the and we have not Q or P. Okay, now we have a very simple law. We have the complement law. And so not P or P gives us equivalent with true. And don't forget the last part, not Q or P. And then the last part, true in something, will give us the identity law. And that will be equivalent with not Q or P. And that is the basic. We can't strip it any further. We have now two elementary propositions, so we cannot simplify anymore. And so this would be the answer on your exam. By the way, on your exam, you're allowed to use the laws on a small piece of paper. We will give it to you during the exam. And so you don't have to memorize. You can always check out what was the name of a specific law. It's more the recognition that is really important. Okay, let's have a look at another example. Now we have not P and Q, or not P or Q. Okay, let's first have a look at it, and then, again, we see that for the first part, the Morgan would be the best option. So let's do that. So we have the Morgan, which gives us not P or not Q, or not P or Q. Okay, and now we only have ors, and with ors you can use associative law. And so let's just do that and remove all the brackets, because I don't care in what order what is done. So not P or not Q, or not P or Q. And then let's just put all the P's and the Q's together by using commutative law. So we put the P's together, not P or not P, and we put the Q's together, not Q or Q. Okay, let's do the last one first, not Q or Q, complement law. And that will give us not P or not P, or complement law, true. Not P, not Q or Q gives us true. Okay, and then let's forget all things on the left, because identity law tells us that if I have an or with true, then this will result in true again. So the final answer is true. So what looks like quite a complex proposition, compound proposition, is in fact always true by just applying the laws. We have a lot of exercises on Teams, so please make them, and there are lots more in the book. And if you have any problems, just contact me. Okay, so for now, bye bye.